Sweet. We are live. Live with Weston and Bernie. Weston and Bernie at 6. We should create a little news station for us.
I say we just go through the do you just want to go through the quiz?
We can. Does it look like it's the same as what the questions in the book were?
It does.
Okay.
So then we're just going to basically be going over the same thing twice, so.
Okay. Let me load that up. Okay, let me pull up my page of what we have, or what I have so far.
Yeah.
So, question 3. Which of the following variables is categorical? Now, there's categorical and then there's numerical, right? Those are the two different types of variables that we've covered.
Mm-hmm.
Okay.
Mm-hmm.
So,
I'm pulling up lesson 2 to take a look at it.
well, it would be the one where it's not including a number, so it would be a randomly selected brand of toothpaste. Because the number of animals in the zoo and the age in years both are numbers?
Yeah, I would agree with that.
Okay. I think it is good that you are pulling up the text, though, because the next question I am not sure about. About the difference between a parameter and a statistic. I remember talking about it, but I don't remember if the statistic is the observed value or if it's the mean type thing.
Let me take a look.
Show summary. So parameter is true but usually unknown. It's a true number that describes a population, and a statistic is an estimate of a parameter that can be obtained from a sample. That's just from the lesson 3 recap.
Okay. So then
that would mean that 100, the mean, would be the parameter, and then the 112 would be the statistic. Because the 112 is a sample of the population.
Mm-hmm. Looks good there.
Now, what did you think on this next one about Rotham City?
Yeah, that's what I'm going back to 2 again. I would say cluster sample on that. What would you think?
Now,
Because
hold on. A cluster sample, that's when we would take just all the, like, in this case, we would just take it just from one neighborhood and take the property value from that one neighborhood, wouldn't we? Or am I? Because I was. Oh, you might be right though. I was thinking of stratified. That's what it is. Where you divide them into
oh
different
no, yeah, you're right, stratified, because it basically says
that
you
you
would divide it and take a certain number out of each strata, right?
right, exactly. Yeah. Let's see. The I think the next one though, it sounds kind of like more like cluster sampling.
Yeah, because you're picking a specific block
Mm-hmm.
and then kind of randomly selecting out of that block. So the specific block would be you
Well,
would choose the specific.
I think they're just getting more and more specific on the block, is all. But then once they get the base block, which would be the fourth grade class, then they just take all of that, or all the students in there.
Okay.
Does that sound right?
Yeah, it sounds like it'd be cluster to me because basically it says cluster is taking all items in one or more randomly selected clusters or blocks. So
Okay.
basically, they're taking all the kids in this specific fourth grade class. So,
Okay. All right,
well,
great. Then the next one.
would that just be simple random sampling?
Yes. Yeah, I think so.
Okay. Next one would be stratified sampling as well, right?
Because you take a block, and then from that block, you take a simple random sample from that.
Okay. Okay.
SPSS. Don't you love it?
Because I gotta do about a million things to get there.
Yeah.
Um, Did you pull it up already?
Yes. I've got the mean and the let's see, what else do I have down? I have the mean, the standard deviation, and the 5-number summary.
Okay. Mm,
I'm just trying to create a histogram now. Oh, there we go. Let's see.
Okay.
But I guess they don't want the 5-number summary, so that's okay with me.
Yeah, just the mean and the
And then the
standard deviation.
Mm-hmm. Do you remember how to do that?
Yeah, honestly, I haven't played around much with SPSS since we first did it.
I don't blame you. From what I remember, you go up to analyze, and then just go to descriptive statistics and select explore. And then once you're in explore, make sure it's your amount in there. And in your statistics, you want to make sure that you have percentiles checked. And then in plots, you want to make sure that your histogram is checked.
Okay.
And then when you run that to your output, it should give you everything you need. The histogram, the mean, median, mode. Actually, I don't think it gives the mode, but it gives everything else.
Okay, that's the Crossroads purchases, right?
Mm-hmm.
Such a pain doing that. I've got like running two different computers off one computer because I'm having to get into theirs, and then I've got the other computer over here.
Oh, man. I just jumped on one computer today. Usually I like to do the 2 computers, but not today.
Okay.
Let me check and make sure that there isn't any other downloads that we need to have. It doesn't look like it.
Okay, and then I go to analyze, right?
Mm-hmm. And then in analyze, descriptive statistics, and explore.
Okay. So our mean is 4.771.
Yep, that's what I have. And then the standard deviation was 1.911. Or sorry, 912.
Mm-hmm.
Good thing I looked at that again.
Okay. Okay, and then you made the histogram.
Mm-hmm.
Okay.
Do you know how to do that?
Yeah, graphs, right? And then histogram.
I don't have a thing that says histogram. Oh, yeah, there we go. Yep, that's exactly how to do it. I did it a different way, though. Okay. I like how they named the elephant seals in this. It's pretty great. Let's see. So this next one we have to complete the table.
So we have to find out the mean, right?
Mm-hmm. Oh, this is not my calculator. Hey, give me just 1 second. I have to run out and grab my calculator.
Okay. Um,
Okay. Fancy calculators are nice, but sometimes I get really confused with them.
so what did you get for your, or have you done the mean yet?
I just got that. I got 38.075.
Okay, that's what I got too.
Oops.
Okay. So they want us to put a negative on here? Or no, we don't, because it's just deviation, right?
Um, I think a negative goes on there, but I'm not 100% sure.
Okay.
And I have the best. Yeah.
Well, I think you're right. So what'd you get for your deviation?
I got. Oh, wrong button. I got negative 0.165.
Okay, that's what I got too.
Did you watch his video before meeting?
I did not have a chance to watch it tonight yet, no. And I noticed he just posted it like a half hour before our meeting or something like that.
Yeah, hopefully he doesn't have anything super important in there about the group work. He probably has something in there about the test, though. Squared deviation for the next one. Okay.
Okay, I got 0.681. What did you get?
I got the same. Now, here's a good question for you. Is that next one? The squared or the squared deviation added up is equal to what? I kind of think it's the variance, but I don't remember exactly.
Well, let me look this up real quick.
Oh no, I got a fatal error.
Uh-oh.
It's okay, I don't think I needed that lesson. Take that. Fatal errors.
Okay, according to this, it says it's the variance.
Okay. And then the standard deviation is going to be, oh, I want to say that there's a square root in there. Square root of this of the variance. Okay.
Let's see, standard deviation formula.
Let's see. Standard deviation formulas.
Oh, it's just your deviation divided by your the deviation of each divided by what? Let me see. square root of the average of the squared differences.
Okay. So this. Sorry, can you say that again?
Let me see. That's not making sense.
So we need to find. Okay, so there's probability, and I'm just looking at the tables from the book. They have a column for probability, and then for the deviation. No. The values times the proportions, and then define variance. And the sum of the variance is the same thing as the standard deviation squared, which means that if we find the variance for each of our values, if we find our variance or the squared deviation and sum those up, and then take the square root of that, we should get the standard deviation.
Okay.
Is that a good? Mm-hmm.
So basically, we add up our different deviations from the mean, divide it by the number of samples, and then take the square root of that.
Sorry, so we find the squared deviations,
Okay.
and then we sum those up and we get the variance, and then we take the square root of the variance and we get the standard deviation. That's my understanding of it.
Okay, hold on just a second.
And I might be 100% wrong.
Okay. Okay.
That doesn't seem like it's right.
Mm,
Oh.
okay, I think I've um, 1.239. Is that what you came up with?
I came up with 1.232, but what I did is I went and put that um, those numbers in SPSS and found the
Okay.
standard deviation that way, and it's not the same. It says that the standard deviation is 0.715.
Okay.
So what I think what we did wrong is that it needed to be the value minus the mean squared times the probability. So I'm gonna give me 2 minutes and I'll have that through my calculator,
Okay.
hopefully. um, I'm starting to remember how to use it, so it goes faster now. Just got one more, and then I just need to add them up. Okay, so it says that my variant should be 0.383525. Now, let me check that with SPSS and see if that's the same variance that they gave me. And it's not.
Well, if you do the square root of 0.38525, it would be 0.621.
Hmm. I wish I'd paid much more attention. Huh, so what should we do?
Mm. You want to put in what SPSS says?
Yes, but I
Okay,
also want to understand how to do it. Um,
yeah, I'm not. I'm not understanding. Because if you add up the square deviance, right? That's what we're doing.
Mm-hmm. If we add those up and square that, or square root that, it doesn't just the right thing, and then
Well, I get 0.621 if I do that again, because you add those up, you divide by the sample, right? And then you do the square root of that.
divide by the sample.
Like you divide by 4, right?
Right.
So if we add all those up, you're looking, if you round to the 0.3, if you round to 3 decimal points, and you add them all up, you get 1.534. Divide that by 4, there's 0.3835.
Okay.
Square root of that is 0.619. Oh, the thing is, only one of them's going to be right.
Well, that's what I got when I calculated it the second time.
Mm-hmm.
So maybe SPSS is just wrong.
I'm not sure.
I don't know. I kind of say let's go with what we got because we. But I don't know.
Do you want to go with that? 0.619?
I kind of do. I don't know. I kind of might be okay with getting it wrong if we do get it wrong. It's
Okay.
I'm fine with that.
Okay.
But
16, standard deviation can be negative. That's false, correct?
right.
17, use different dolphin, use different seals this time. That's going to be extradural, correct? Is that what you got? Because it has the smallest standard deviation.
Which location has resulted in most consistent temperatures? I think so.
That's what I went with because, like I said, that's the smallest standard deviation.
Right. Makes sense.
Okay. I can define standard deviation in my own words. Okay, true.
What is okay? So number of students. Use the box plot. So what is the third quartile?
It's going to be 8, right?
Yes. What percentage of data lies between 4 and 8 hours?
50.
Okay.
I mean, is that how you understand it?
I don't remember. I was thinking, first thing that came to mind was the 68, 95, 99 rule, but I'm not, that doesn't sound right.
Well, because these, I think, use
Because,
the histograms. I don't think use that
right,
rule. They show quartiles, not the
right,
68.
exactly. It's,
So,
oh yeah, it is 50%. Yeah, because
okay.
the third quartile is 75%, and the first quartile is 25%. So yeah, okay. I was just thinking too hard.
Okay.
Estimate the mean of measured nitrate concentration in Rexburg's drinking water.
Okay.
Hi, you've reached the Brenners. We are unable to come to the phone at the moment, but leave your name, number, and a brief message. We'll get back to you as soon as we can. Thank you. Bye.
Okay.
Do you understand what it's saying when it says we assume 1.59 parts per million is the value of mean or mu minus 2 standard deviations, and mean plus 2 standard deviation is equal to 2 point. Oh, okay. I just had to read it out.
So,
I got it now.
so U is mean, right?
Right.
So U minus 2 standard deviations is 1.59, and U plus 2 standard deviations is 252. So we just need to find the midpoint between those two for our mean, right?
Right, and we can just take and set those equal to one another, right? Like, we just have to rearrange it, but... Yeah.
Okay. What are you through the math yet?
Not quite. Close.
Wait, are you still doing homework? Huh? Next.
Okay, so for the mean I got 2.055.
Okay, that's what I got too.
Okay, good. I was a little bit worried. And what did you get for the standard deviation?
0.233.
Okay, sweet, me too.
Okay, which is going to make 23, 1.822, and 2.288, right?
Yes, I believe so. I'm not. Yes.
Because 68 is going to be within one standard deviation, so it would be 2.0
Right.
plus the one deviation and minus one deviation.
Yeah, I just had to punch it into my calculator real fast.
Oh.
Did you do that in your head? Because if so, I'm impressed. I'm horrible at doing decimals in my head, no matter what they are.
Okay. What is the value of the mean of a standard normal distribution?
Is it Is it still going from the same set of data?
I'm guessing.
Then it would be the same as 21, right?
I would believe so.
Okay. And then what would be the value of the standard deviation of a standard normal distribution? Here's the thing, I feel like those are way too general for the last set of information. What do you think?
Let's see.
Distribution.
The mean of the sample means is always u, so that should be the same, right?
Think so?
It says the following facts are always true. They do not depend on the central limit theorem. They do not depend on sample size. These facts hold for the sample mean x of any sample, random sample of size n drawn from a population with mean u, a standard deviation of O. The mean of the sample mean is u, so it would be the same. And the standard deviation of the sample means is always O divided by the square root of n.
Okay. My question then is, what is our n so we can find out the standard deviation? Or, sorry. Yeah, so we can find the standard deviation, because the mean would be the same.
Would you just use 1?
Oh, hold on. So this is in the lesson 5 recap. It says a standard normal distribution has a mean of 0 and a standard deviation of 1. And then talks about the 68, 95, 97 rule. Could it be that simple?
Let me see. Chapter 5, normal distributions.
I think it's that easy. And if not, I have a good case for why it should be that easy. Because that information, it does say use that information for questions 21 and 22. Granted, question 23 wasn't involved in that, but I don't know.
Well, you said that was in chapter 5?
Well, it's in, if you go to the where you got the questions for on lesson 8,
Uh-huh.
there's a button over to there's a link over to the side that has the summaries for each of the chapters,
Mm-hmm.
and so that's where I'm looking. Is just in that, in those recaps for the chapters.
Hmm. Okay. We'll go with it.
All right. So the next.
Yeah, we get our applet.
Yeah. I feel like we've done a lot with this, so I feel kind of comfortable with this. We do z-score, we do probability.
Okay. So,
Oh, shoot. I did that wrong. I'll find the z-score. Or I'm finding the z-score fast. Points.
well, it's got to be a .50,
Oh, you're right.
right?
Yeah, because the score is the same as the mean.
Yes. So half are going to be above it, half are going to be below it.
Yeah. Good call. What's the probability that they'll do it below that?
Okay, this one we'll actually have to figure out.
Okay. Below 600. I got that it was 0.684 for the probability.
That's what I got is .6842.
Okay. So then the next one just wants to know what's the probability that they'll score above that. And that's going to be...
.316.
Yeah. Okay, so from the GMAT score, the corresponds to the 10th percentile?
That I'm not sure about. Do you remember those?
Vaguely. So for the 10th percentile on the normal probability applet, in the area, we're just going to put in 0.1. And then we can take that z-score, and with that z-score figure out what that value is.
Okay.
Does that make sense?
Mm-hmm.
Okay. So z-score times the standard deviation subtracted by our mean should give us our value. Z-score is 1. Oh, might have done that. I got a negative number, so I don't think that's right. How does 696 sound?
That's not what I got.
What did you get?
388?
Did you get a negative 388?
No. Because
So you,
I was thinking, because we're trying to find our z-score is negative 1.282 equals, and then it'd be x minus 542.3 over 120.54 divided by the square root of 1, which is 1. So you basically times both sides by 120.54, right?
mm-hmm.
So then I got negative 154.53228 equals x minus
Okay,
542.3.
you're right.
Add 542.3 to both sides.
No, you're right. I was thinking 90th percentile.
Oh, okay.
So I got the answer for the next one. Because I used the positive z-score is what I did, and went everything
Oh,
above that.
and that was 6 what?
697.
Okay. First quartile and third quartile. So we're going to do the same thing but with those.
Mm-hmm. So 0.25 and 0.75.
Hmm.
Okay.
Okay, did you get 461 for the first quartile?
Yep.
Okay. Third quartile. $624.
Yep, that's what I got.
Okay.
And then the next two, I think, are pretty easy because it's asking for the 33 is asking for the mean, the sample mean, which is just going to be the same as the normal mean.
Yep.
Okay, so that's 542.3.
Yep.
And then the standard deviation is going to be standard deviation over the square root of 15. Okay. And I got 31.123.
Yep.
Okay.
That's what I got too. Okay. So then we're going to do probability 600 minus 542.3 over 1.4 divided by the square root of 15.
Yeah, I got the z-score of 1.853, or sorry, 854. Did you get that as well?
Just a second.
Okay.
$1.854.
Yep.
Okay. .032.
Yep, that's what I got.
Okay, shall we submit it?
Sounds like gold to me. See? Oh, 94. Pretty good.
Let's see what we missed.
It
Oh,
was
14.
14 and 15.
14 and 15.
The standard deviation ones.
Yep. But we got everything else. If I get a 94 on the test, I'll be happy.
You can. You've got this. Hopefully I've got this. I'm telling you, Bernie, group test, that's what we need. You still there?
Yeah. Just glitched on me for a second.
That's okay.
Okay. I'm
Well,
going to go ahead and submit this. Good luck on the exam.
same to you.
Okay.
Have a good one, Bernie.
See ya.